vector khachut ya kan zir chin kha kan du tok mai nga tuna chuan motion in a plane ti an zile to nga page 2 430 and motion in straight line kan ting straight line is one dimension. That is when you study motion in straight line, it means that motion of particle in one dimension. Now we'll proceed to two-dimensional motion. That is a plane. A plane means, suppose I have a flat surface here, that is tables, for example. I have two dimensions. Dimension pakhat kanaya upward direction kanaya horizontal direction kanay le bokta then entire life force ang here horizontal direction pihin kanita a vertical direction ania. Suppose this horizontal direction is represented as x and this is y axis. And it's one I have two dimensions. These coordinates and the coordinates are perpendicular to each other. X and y are perpendicular to each other, and if a body moves straight line along this direction entire here, if this is the origin at t equal to 0, that is at initial, when time 0, that is initial, a body is at origin, that is the distance or displacement along y-axis is 0 and x is also 0, and after some time when a body reaches this point, so the displacement along y-axis will be length of these 2 points. That is the displacement along y-axis, and displacement along x-axis will be distance between origin and this point. That is displacement along x-axis. So if a particle moves along or between the two axes, axis is singular form and plural form is axis. Plural. So if a particle moves along this path, then that particle will have displacement along both axes x and y, that is this distance and this distance, that is in two dimensions. When we consider only one dimension here, a particle moves along this path, so we take only the displacement along this path. We never take along the displacement along upward or downward. We only take along this path. That is one dimension. One dimension and two dimension tang lam na ni tani. Chuanin tuna chuan let us consider position vector. Let's try to find out what is position vector. Suppose a body is placed at this point in a table, for example, then I will want to find the exact position from one of the corners of the table, that is O, that will be our origin. Then how will I do that? I'll measure the distance of this position object, suppose A, from one side of a table, that is, in our case, this is y-axis, and similarly, I'll measure the distance of A one side, another side of the table, that is in this case x-axis, So suppose point, this is B, this is C. So AB is, for example, 5 feet. 5 feet. And OC is 4 feet. So from 4 feet, I'll measure this point A, and from 5 feet, I'll measure point A, and I'll take the position. And then I can know the position. That is, I'll draw a straight line here. So if I know this is 4, that is, this BA will also be 4, and here I have 5. This is 90 degrees, so I can use Pythagoras theorem to find this length. So I can know exactly where object is on the table. Then what exactly is position vector? Position vector is the distance between origin, here is O, and A, that is the object. That is position vector. And we usually represent it as R. Here is R. So on. X means X exists. I, here is I cap. We have I cap, J cap, Y cap, K cap. We have 3 position vector, unit vector. These are called unit vectors. Unit vector kan ti chuan internet ta hian point A ki a ta hian a awm ani ti in ka thian pa khan point A ka khuya nge awm lo ti ta ni mi ron zot ta a object ka khuya nge ka ta ti mi ron zot ta kin head origin chingin khi ta khin ka kok chho ta ni ka ku zum changin khi ta khin om khi so ti lai so om khu ta khun om khat tiang kan ko na kan sui na over there kan ti te down there, it is down there, it is over there, it is up there, it is upstairs, it is behind me, it is in front of me, it is in my left side. These are called unit vector, and in mathematics we give unit vector value as 1. That is, I dot square will be equal to 1, and similarly J dot square is also 1, and K cap square is also 1. If I square these unit vectors, I'll have 1, because in upward direction I may have it is taken as 1, in downward direction it is taken as minus -1. If I square -1, I'll get 1. So square of this unit vector always give 1. It's a clear vector. And one thing we have to note is I dot J, these are cap, equal this dot product. J dot K equal K dot I, all as cap. These are 0. This gives 0. I dot J, J dot K, K dot I, or I K dot K dot J, or J dot I gives 0. Remember this one. But if I take I cross J, I'll have K, K, and the rest I will not write it, I just explain it. I cross J will gives K. That is, this is in 3 dimensions. I have drawn 2-dimensional diagram, And if this path is along z axis, that is k, so I'll draw from the beginning. If I draw another z direction, suppose this is direction, this x, y, z perpendicular to each other. So I have k over here, that is z direction, k. That is, suppose this is x-axis. Let us take x-axis for more convenience. That is I cap. That is y-axis. That is j cap. It is x, and this is z-axis. So I cross j means if I move from I to j, I to k. That means I to k through j. That means if I move from I to j, I'll reach k. That is cross product. As I've already said, cross product is a rotation. If someone is rotating from this position and finally it reaches k, z axis. And if I move from j to k and finally I reach I, that is j cross k will be j cross k will be I cap. And if I move from k to I, finally reach j, that is k cross I will give j. Kakatil akal dan sunitani o tekan rotation tekan kalta. Cross product is a rotation dito ka. Then what happened if I move from j to I and finally reach k? J cross I still gives k, but the sign will be changed, so I'll get minus k cap. If I interchange this k and j, k cross j, that is, will give minus I cap, and minus I cap cross j will give minus j. Kahuka, please write down on your note. Thanks for making a zel don. Tika, ta ila chain karya. Chuanin tikan vector b ka chuan kan zero thathok khat thon karya a kadu tok rianga vector b ka kan chuan tuna ka kalle na tur chu displacement an kan ka to displacement. I have displacement and distance. They are same but have only one difference. So what is displacement? If a particle, this is stable, this is one side and this one side, and this is another side and this another side, but these two sides are not necessarily joined here, but because we don't need it. So if a particle or a marble is moving on the table, and the part of the particle moving on the table is like this, and finally stop here. So now we have to find what is the distance traveled by the marble. So the distance traveled by the marble will be the length, real length, full length of path followed by marble. That is, suppose this length is 6 feet. 6 feet. The total path length of marble is 6 feet, and that is the distance. Now I want to measure the displacement. That is the distance of the starting point of marble and final point. where it stopped. So I'll measure this distance that will give displacement. So if the distance, the real distance traveled by marble is 6 feet, and from the diagram it can clearly clear that the displacement between this and this point must be less than 6. So we have to remember that point. This is the displacement. This part is the distance. So displacement may be less than or equal to distance. That is a good question. Can be asked. The example sum. Displacement may be less than. Yeah, it is less than or equal to distance. When is the displacement and distance are equal? Suppose if particle travels from this tip to this tip up to this, so the distance traveled by the object is the distance, the total path length. This is this one, that is this one, and the displacement also is the initial point and final point distance. So these are same. If I take the same, I take the magnitude. So distance and displacement are the same here. That is in 2 dimension. In 1 dimension, this is 1 dimension. Here's 2 dimension. In 1 dimension, the displacement and distance are equal. We have to remember that one. And displacement is a vector quantity. Displacement is a vector quantity, while distance is scalar quantity. Oh, it's a scalar. Displacement is vector. Can be 0, negative, or positive. But distance is always positive. So again, distance is a scalar dia, a scalar dia, a vector ni, teka, kanchadonia. And the rest topics here we have to derive all these, but we'll not do it because we have already studied in the previous unit that this velocity is distance by time dA. A velocity token along x-axis. Along y-axis, x will be replaced by y. And if I want to find along z-axis, dz by dt, this will give velocity along z-axis. So we'll not do it this type of problems. And next, acceleration also will not do it here. The acceleration tunjukkan z bahwa we have already studied in the previous chapters. Kan kita don't know. So I will switch over to projectile motion. Projectile motion, but we will do in the next video. So that's all for today. Then we will not have home assignment today. Don't know, have a nice day.